This is section 3 of chapter 11, and in this lecture we'll talk about the types of factorial designs and analysis. So, factorial designs come in many varieties. You can have designs with separate groups per treatment condition, that is a between subjects design. And you can have true independent variables, meaning variables that are manipulated by the experimenter. However, you can also have the same group of individuals participate in all treatment conditions, and that's called a within subjects design. And factorial designs can accommodate quasi-independent variables that are pre-existing and are not manipulated by the researcher. And furthermore, the same study can include both within and between subjects factors. So researchers can address more intricate scientific questions by blending together different designs and different strategies. And that's what we're going to consider in this lecture. So in the past lectures, we've discussed between subjects and within subjects designs. And again, between is when different groups of individuals undergo each treatment condition separately. And within is when the same group of individuals undergoes all the treatment conditions. Now, factorial designs can be between subjects, within subjects, or a combination, as we'll talk about later in this lecture. And each design has its own pros and cons, as we've discussed in the past. So let's recap. So for between subjects designs, some of the disadvantages. Well, one, it requires many participants, especially if you have many conditions. So if you have a 2x2 design and you want 30 people per condition, well, that's 4 conditions, meaning you need 120 people to participate in that study. Next, you have the problem of individual differences. So variability among participants can confound the results and increase the variance of the scores in the conditions. But on the plus side, the advantage is you don't have to worry about order effects. The scores are independent from each other, which avoids order-related biases and confounds. So this study is best when a large number of participants are available and individual differences are relatively small or can be minimized, and where order effects may be a problem. So factorial designs can also be within subjects. And here are also disadvantages and advantages aplenty. So the disadvantages. One is participant attrition. People may drop out due to the time-consuming nature of undergoing multiple treatment conditions across time. Then you have to worry about order effects. So repeated measurements can lead to fatigue and practice effects and other testing effects. On the other hand, some of the advantages is fewer people are needed. It requires only one group of participants who are going to go through all of your conditions. And also, reduced individual differences. This design eliminates variability among participants since the same individuals are used across all of your conditions. All right, so Between or within? That is the question. And it's a difficult choice. But there is no law of nature that stops you from combining these designs into one. So a mixed design is a factorial design that combines two different research designs. And it allows researchers to leverage the advantages of both while mitigating the disadvantages. And a common example of mixed designs involves combining between and within subject factors. So this flexibility allows researchers to handle factors differently depending on their characteristics. So for example, using a within subjects design for one factor to reduce the number of participants needed, and maybe a between subjects design for another factor if you are trying to avoid order effects. Let's consider this example here of a mixed design study. So here we have a study investigating the effect of acetaminophen, Tylenol, on the perception of pain and pleasure, emotional pain and pleasure. So this was a 2x2 design, but one factor was between subjects and the other one was within subjects. So the participants were divided into two groups, two separate groups. One received a dose of Tylenol, acetaminophen, and the other received a placebo. So that was the between subjects factor, the type of treatment, either acetaminophen or placebo. Then all the participants from both groups viewed a series of photographs, some depicting highly positive images like kitties and kittens, and others depicting very negative, unpleasant images like starving kitties and starving kittens. So the within subjects factor was the type of photograph, pleasant or unpleasant. And the dependent measure was a rating of pleasantness or unpleasantness for each of these photographs. Now the findings shown here are very interesting. And the findings are that the acetaminophen group rated both positive and negative photographs less extremely compared to the placebo group. So this suggests that acetaminophen reduces the emotional experience of both pain and pleasure. There's like a dulling of pain and pleasure caused by acetaminophen. So in this study, it made sense to use a between subjects design for the type of treatment. It makes sense for the placebo group to be a separate group of individuals than the treatment group, the drug group. But the photograph, the type of photograph, pleasant or unpleasant, was kept within subjects to leverage the advantages of the within subjects design. Now recall, research strategies can be categorized as experimental, non-experimental, or quasi-experimental. And these strategies differ primarily in how the variables are manipulated and controlled. So when it comes to factorial designs, it is possible to use factorial designs for experimental, non-experimental, or quasi-experimental studies. And the variables that are not manipulated are still called factors in these studies. And just like it's possible to combine between and within subjects factors into a mixed design, it is also possible to combine experimental, non-experimental, and quasi-experimental designs into what is called a combined strategy. So again, as we were just discussing, combined strategies will use perhaps an experimental strategy for one factor and a quasi or non-experimental strategy for the other factor. And so these strategies will often consist of a true independent variable, a variable manipulated by the researcher to create the different conditions, and a quasi-independent variable that may include, let's say, pre-existing participant characteristics like age or gender, or time, like comparing the immediate and long-term effects of two different therapies. So the gender and video game violence study that we discussed at the beginning of this chapter is a great example of a combined strategy of this type. Because, if you recall, there was an independent variable, which was the level of violence in the video game. This variable is manipulated. And then there was a quasi-independent variable, that of the gender, male or female. And this, of course, is a pre-existing characteristic that is not being manipulated by the researcher. And so the findings, as you may recall, is that video game violence seemed to result in increased aggression in males, but seemed to have little to no effect in females. So these designs will enable researchers to address questions that single strategies can't really answer alone, and thereby providing a more holistic understanding of the variables under study. All right, so we introduced mixed designs and combined strategies. Now let's think all the way back to the last chapter. And recall, we discussed in the last chapter something called the pretest post-test control group design. Now this is an example of a two-factor mixed design. Why? Because you have a between subjects factor, so which is groups, treatment group or control group. And so this factor distinguishes between participants who gets the treatment and who does not. And then you have a within subjects factor, and that is the measurements, so the pretest and the post-test. And this factor measures changes within the same individuals over time. Furthermore, if you were to use random assignment to create your groups as opposed to using pre-existing groups, then this could become a combined strategy with one experimental factor, that is the treatment or control, and a non-experimental factor, which is the pretest post-test. So here we have a visual depiction of the pretest post-test control group design. So this is considered a mixed design because you have two factors. One is a between subject factor and the other a within subject factor. So the groups, treatment or control, would be a between subject factor. You have different individuals. And all the individuals will be tested at these two time points, pre-test and post-test. So this second factor would be a within subject factor. So hence we have a mixed design. Now, if you were to use random assignment in the creation of the treatment and control group, well, now this becomes an independent variable and an experimental strategy. So now you still have a mixed design which combines between subject and within subject factors, and also a combined strategy which combines experimental and non-experimental strategies. And let's just briefly mention the idea of higher order factorial designs. And this was alluded to earlier in the lecture, but the idea is that you can extend your factorial design beyond a measly 2 factors. You can have 3 factors, for example, or 4 factors or more. And so with 3 factors, you're looking at 3 possible main effects and a lot of interactions. So you would have 3 possible 2-way interactions and 1 3-way interaction. And so designs that include 3 or more factors are referred to as higher order factorial designs. Now, as you may imagine, adding more and more factors to your study makes things more complicated. Not just to analyze, but also to interpret and understand what your findings mean. So you're within your rights to consider a higher order factorial design, but proceed with caution. All right, just a few words on statistics to close out this section. So the statistical analysis of factorial designs varies based on whether the factors are between subjects, within subjects, or a mixture of both. And typically, the means are computed for each condition, and then an analysis of variance, called an ANOVA, will tell you whether your differences are significant or not. And so the ANOVA indicates if you have significant main effects of your factors or significant interactions between the factors. And you could have both or neither. And we'll talk more about analysis and statistics later in this course. All right, that concludes this section. And the next section will consider applications of factorial designs.